What's up guys, this is Peter from Team Xtrapy, and here's a brief explanation of our Worlds robot. So we have a puncher bot, which is actually quite popular here in China, but surprisingly we didn't see many of those at Worlds. Originally we were actually inspired by Purdue, so thank you Purdue for giving us the idea of a puncher. And let's start with the drive. So on the drive we're running 450 RPM on 2.75 inch wheels. We have 6 motors, 600 RPM, geared 36 to 48. And we have 8 wheels to reduce the amount of which the robot sinks into the foam tiles, which helps with consistency and mobility. Thank you, Joey from Team 42B for the suggestion. Next, we have these high-strength axles traversing the drive horizontally, both in the back and in the front here underneath the intake. This actually helps us reduce the torsion that the drive experiences in this direction, so that we can have a sturdier drive. And we have this big Lexan piece in the back because in one of our scrimmages, we had the teams have their wedge stuck right in there, this little compartment. And our robots weren't able to separate until somebody manually pulled us apart. We don't want that to happen again in Worlds, so we covered up the entire back. And also it's good for decoration, although now it's pretty messed up. And on the sides here, we have double stacked Lexan plates that we put on the sides as a kind of rail to help us go over the barrier. So you can see that they're angled like such so that they help us kind of gradually climb onto the barrier. And also, if I can lift this robot up a bit, you can see that they're slightly lower than these 36 tooth gears there, and that's to prevent them from getting caught on the barrier. Another interesting feature of our drive is that the front and back wheels are actually mounted on screws rather than axles. So as you can see here, there are plastic inserts that the screw runs across. And here are 2 tiny standoffs on this side. This screw ties the standoff to this C-channel, and on the inside there's a longer screw traversing the entire width of both the wheel and the gear, which are bonded together using these 4 screws. What's good about this part is that the screw, although it does leave a little bit of sliding room horizontally for the wheel, it actually tightens this C-channel and this C-channel, so it acts both as a piece of structural support and an axle. So that allows us to basically reinforce the strength of the drive without having to add additional friction to the transmission, so that we can, engage in defense with more confidence, as well as go over the barrier without damaging the overall structure. All right, and now moving on to the intake. We have a 3-stage intake. First stage here, second stage here, and third stage is right there beside the puncher in our little hopper. So first starting with the bottom stage, we have 2 angled C-channels here and here to act as rails for the discs, so that we basically have a larger margin of error to intake the discs from. And we have the flex wheels positioned in the middle so that when the discs are on the very side, these flex wheels would grip on these the relatively higher margin of the discs, so that it can have a greater force. We actually had rollers on the side before, but they didn't work well because when the disc is lined up against this piece right here, this flex wheel would counteract against this one, which kind of slows down the entire intake. So to demonstrate, I'm just gonna, yep, that's how the intake functions. Let's try one from the side here. Yep, it slides in like such. And we actually have an interesting mechanism right here. So this is actually a sliding spacer, as you can see here, a rotating spacer, I mean. And that helps us, when we intake discs from the side, when it goes to about this position, sometimes the disc gets lined up right there. And this actually helps the discs automatically adjust so that it pops up in the middle, like that. The disc kind of just slides off this spacer very easily. We have a half-cut 3-inch flex wheel here. We have it half-cut because, first of all, it reduces weight, and second of all, we don't need that much friction, and we need a little bit of flex on this flex wheel, so that the intake would have less resistance when the disc goes up. On the back here, we actually have custom PET plates. So it's bent, as you can see right there, and it's actually supported by these two black rubber bands. So these kind of just pop up the plate by a tiny little bit, so that we can make sure the 3-inch wheel, the 3-inch flex wheel would contact the disc right after it leaves the first stage. That actually reduces the amount of how these two stages counteract, which kind of speeds up our intake overall. Another feature is this lifter right here. So this is fairly simple, cylinder mounted from here to here, which lifts up our intake like that. And that helps us intake a 3-stack. So let me see if I can show this with one hand. Like that, yeah. And all 3 discs go into our hopper right here. So here we actually have custom Lexan pieces, also double stacked for the intake. And that's because we wanted to absorb the shock when we actually play defense or an opponent robot crashes into our intake. We used to have half-cut C-channels here. It got messed up really badly. So the way these Lexan pieces work is that they have a little bit of flex in this direction. However, these spacers stop them from going too far, like this, boom, they stop right there, to prevent the Lexan from snapping right away. We run 2 chains here to, ensure that if one breaks, the other one can still help the intake function. Thank you, Ben from 5 Entire Power, for the sticker. And here is how the transmission works. So let me take these discs away. This is a 200 RPM motor right there. It powers the axle, this axle below. The power goes over here. We actually have this tiny little gearbox here that runs 3-to-1. So this axle running on the 3rd stage is actually 600 RPM. And here's something really interesting. So here we actually hammered the axle so that this pinion gear wouldn't fall off, because we didn't have a space for the shaft collar. So that's basically a trick we did to prevent this from falling off. Right here, we also had our team plates mounted as somehow a protection to this chain right here. So right on top, this is our hopper. We have this small flipping cap to kind of maintain the disc's position before shooting. So the first one goes up like this, second one, and third one. So they kind of just stack up below each other, and there's a constant force supplied by these rubber bands that kind of press onto the discs to maintain their position and orientation. So this cap is mounted on these 2 shaft collars with standoffs, and they rotate on these 2 screws. And on the side here, you can see that there's this little aluminum piece right here that connects to this piston. So when we want to flip open the cap, we just push this piston outwards like such. And right before we shoot, we open the cap to, clear way for the disc's trajectory. And we do so by just activating the piston right like that. So when we shoot, we just do this. Also, right here, we have a distance sensor that points diagonally into our intake to count how many discs are in our robot. So we run a task throughout autonomous and drivers to constantly keep this count. And we run an algorithm that determines if there are 4 discs in our robot. If there is, then we run the intake backwards to outtake the 4th disc before we activate the puncher. And that is to automatically kind of prevent us from getting disqualified for scoring with 4 discs in our robot. So let me just demonstrate that real quick. I'm gonna intake 3 discs first. All right, and let's put a 4th disc in our intake like that. So as you can see here, the distance sensor can detect this disc right there. And right before we punch, we can see that the intake would run backwards like such. So technically, this would not count as a DQ because if you're watching in slow motion, this disc actually gets out of the robot before it actually punches. But we left the time period very small to, you know, reduce the amount of lag that it would have on our puncher. Okay, so on the front rollers, on the same stage as the second stage of the intake, we have two chains running up towards these two front rollers. We didn't manage to get an axle connecting these two because it would just block the trajectory of the discs from the puncher. And we had these two plates to protect these discs from ramming up to the rollers and breaking, which happened to us before we had these. Moving on to the back roller, it runs directly from this axle right here, from this sprocket to this sprocket. So this is basically 100 RPM, 1 to 2. This is fairly simple, just one high strength axle connecting it from left to right. And I forgot to mention the RPMs for my intake. So the first stage is 450, the second stage is 300, and the third stage is 600, if I remember correctly. All right, I think that's it for the intake. Right, so next up is the puncher. This is what we've been working the most on throughout the season. We have a puncher with variable range, meaning we can basically adjust its power like such and shoot from all over the field. It allows us to accommodate for both autonomous and drivers. Just release it so that we can start explaining. So at first glance, you can see that there are two custom Lexan pieces right here that hold both this pinion gear and this 48 tooth gear. So what happens is that basically this pinion gear actually doesn't touch the rack here. However, this 48 tooth gear does. So let me see if I can get a better angle in front of here. So yeah, it's pretty hard to see, but right there, the pinion gear doesn't touch the rack here. So when these pistons push downwards, this gear actually latches onto the rack of the puncher and pulls it backwards to load it. And when we need to shoot, we just lift these pistons upwards. That pulls this 48 tooth gear away from the rack to allow the puncher to shoot forward. So let me just demonstrate real quick. When it loads, it pops down to load it, and when it shoots, the two cylinders pop up like such. So the interesting part about this mechanism is that we only have these two very little rubber bands to power this, to push the cylinders downwards so that this latches onto the rack. And this is kind of counterintuitive given how powerful this is. However, we designed the geometry of this lever right here so that the force of these rubber bands pulling forward would actually automatically lock this gear in place. So the resultant force of this whole mechanism actually pushes this gear towards the rack. So this gear is kind of like wedged between this pinion gear and this rack in that downwards direction. And we need two cylinders to pop up this 48 tooth gear, as I said, due to the automatically locking force. So what's interesting is that we actually modified the geometry here again so that we can pop up this gear more easily to, you know, reduce the air usage of the puncher so that it can last throughout the entire match. Originally, we actually had a 36 tooth gear here instead of a 48 tooth one. So you can imagine if the gear is smaller, then the lever between this axle and this screw right here would be at a smaller angle, like it's lower in that direction with the rack. So the lever, how the geometry works, renders the previous version harder to pull up than this one. The current version allows us to get 20 plus shots without running out of air, and that's definitely enough for a match. We would never run out of air mid-match, so yeah, it worked pretty well for us. And for the actual sliding mechanism itself, this T-shaped thing right here, this is actually made through a lot of custom Lexan parts. We have an exact replica right here, not actually exact, there's a slight difference. And what's funny is that we were gonna use this as a backup for Worlds in case that one broke, but actually this one broke when we transferred it on the airplane first before our bot actually broke. So this never got used, but I'm just gonna use it to explain. So what happens is that as you can see, there are Lexan plates here and on the side here. Two sets of rotating spacers kind of wedge this whole mechanism between. There's one group down here and one group up there to kind of wedge this in between, and there are 4 in total that kind of hold it from these 2 points and these 2 points. So I'm gonna try and locate those on my robot. So there's a group below that you can't really see, but never mind. There are a group here, and there are a group right over there, right beneath this half-cut C-channel. So basically these rotating spacers kind of prevent the puncher from going like in this direction, and the width of this Lexan piece prevents the puncher from moving in this direction. So that basically limits the action of the puncher so that its only direction of movement is sliding back and forth like such. And for the power transmission of the puncher, we have a 200 RPM motor powering this compact tiny little gearbox right here, 12 to 36 to 1 to 3. About 66 RPM delivered to this pinion gear right here, which is delivered to this entire rack. So this gear actually doesn't determine the speed of the puncher's loading because the rack is essentially gear. So what really matters is the size and speed of this pinion gear and the rack itself. So this is just transfer gear in the middle. And that's why we had no hesitation before switching this out from a 36 tooth to a 48 tooth for the benefit of lifting the pistons to shoot the puncher. Right, I guess that's it. Oh, one last thing. These rubber bands, we stretched them all the way on top to there rather than just a tiny piece here, because we figured that the smaller the ratio between the amount of stretch of the rubber band and its original length, the more the rubber band's longevity would be, like the more little variation they would have over time. All right, and next up is our expansion. So this expansion has 28 tile capability, and it's separated into 2 stages, the one above and these 2 below. So the 4 here above are all connected to a single release mechanism, that is this high strength axle. It actually holds these still by this trigger here. So as you can imagine, these rubber bands are pulling in this direction, so forwards, and that makes the axle rotate counterclockwise. So therefore this spacer actually gives the force in that direction. So with this custom Lexan trigger, when we actually push this piston upward, this goes downward and therefore releases this spacer. And this actually just barely touches this one, so that it wouldn't have too much friction. And now it basically just completely stops the force of this, because this force right here acting in that direction and this spacer stopping it from moving acts at a 90-degree angle. So basically that's how we kind of load our expansion. We never had it fire ahead of time ever during our match, so that's pretty nice. So for the actual expansion itself, we have these half cuts, although they're actually cut from medium width 3 channels with 3 holes wide, so that we would actually have a bit more space here for mounting the wires so that they wouldn't fall off the string, I mean. So these are actually not that good, but we kind of rushed the expansion before Worlds. We just figured out that it could hold itself up by friction, and that's what we went with in the end. In the bottom, there's like a bar that holds its position, so that the angle of these 4 would be consistent. And okay, moving on to the ones below. These ones are a bit more interesting, I would say. So the key is basically here and here. There are 2 shaft collars, as you can see right there, that we actually drilled holes on both sides and threaded. So originally the shaft collar only has a threaded hole on one side, but we actually drilled a hole 180 degrees to that. So we have this kind of two-side pivoting mechanism. And that basically allowed us to put the trigger below and load the string on top. And this really allowed us to, reload this mechanism really conveniently between matches, because we wouldn't have to worry about this being blocked by the trigger while, wrapping the string around. And the way it releases is basically these are attached, these spacers are attached to this cylinder on a pivot here, so that this lever would push in that direction and this little metal piece would rotate counterclockwise. And this would basically pop forward, allowing this to go backward and this to go forward. So when this goes forward, it just releases this zip tie right here, a bunch of strings right here, and this little pinion gear gets launched out as the expansion. So basically the same as the ones above. It's only that the triggers are slightly different. Yeah, I think that's it for the expansion. All right, and that's about all I've got about this robot. Thank you all for such an amazing journey. Congratulations to Kaptan and BarkBots for winning Worlds, and also special thanks to Xenofox for supplying me these rubber bands for emergency when my old ones didn't pass inspection. Guys, it's been such an amazing season for me, and it's probably my 9th and final year in Vex, but who knows, maybe I'll be competing at Vex U again. So anyway, thank you all so much, and good luck in over under.